Hello students, welcome to today's session of Dairy Chemistry Dose. So the endeavor of this particular series of Dairy Chemistry Dose is to help those students who are appearing for this year competition for advanced JEE mains or NEET examination. So my endeavor is to take up 4 or 5 concepts and teach them through a problem solving. So here the endeavor of all these videos in this particular playlist is to teach you or to revise your concepts through the problem solving. So here comes one question. This video also gives you a good amount of direction in many aspects. What is pyrolytic elimination? What is pericyclic or EI elimination? What are these? So let us first take up the question. Just go through this question by pausing the video, try to solve it, and thereafter see into the discussion which I am going to do. So I hope you people have tried this question by pausing this video. So what basically it is being asked is you have to identify the incorrect statement for which type of reaction, for what type of reaction it is. Secondary butyl acetate is heated to 440. So basically it is the pyrolytic elimination of secondary butyl acetate. So basically you are treating a given ester or strongly heating it, and thereafter you are thinking of creating some products. And what are those products? They are being tabulated in A, B, C, D option, and you have to figure it out which is the incorrect statement. So let us first understand what exactly. So I have seen most of the time people are not clear with the first the nomenclature of ester. So if I talk of the nomenclature, alkyl esters are the class of compounds in whose IUPAC name two times alk is coming. One alk is here, another alk is here. So basically it is alkyl, then again alk. So this alk in a way represent the number of carbon atoms. Say for example, if I draw it like this, if I draw one ester like this, so there are two alks here. One alk is belonging to this, another alk is this, because alk is the number of carbon atoms. So this this is basically the part of this alkyl, and the part which contains the carbonyl group is the part of this one. So basically the name would become in this particular case is ethyl ethanoate. So at times I have seen that if you are not able to understand the naming or not able to understand what exactly is the structure of the compound by seeing the name, just here, see here, it is secondary butyl acetate. Now you also have to understand here the name which is being given to you is a common name. This alkyl alkanoate is a IUPAC name. Similarly, alkyl benzoate, if I have to write, so it is, it can be written it like this. This is benzoate part. If I draw it like this is benzoate, and here you have some alkyl, so this is methyl benzoate. So this way you can learn this one also. Now as regard to the common name, you should know that this entity is commonly said as form, and this type of a moiety is said as acet. So now what is being given here is, if say for example I have to write its common name, so this part if I talk of, this is nothing but form, and this part is the part of alkyl. So alkyl comes in the front. So what now I have to write, because this is nothing but acid, this is ester part, this linkage is ester linkage, so it becomes alkyl formate. So if you could recall that in the IUPAC naming, this is O8, this O get omitted in the common name. So another one, if I have to write it once more for you, so this is what part? This is acet, and what is this alkyl part? This is methyl, and lastly for this part you have to wrote it as 8, so it becomes methyl acetate. And similarly what is being given is, this is nothing but butyl, this is the butyl part, and this is what you call it as, if I talk of this one, this is acet, and it is acetate. So butyl acetate. Now butyl is being given to you, which butyl it is being given? Secondary butyl. Secondary butyl. Now the matter of the fact is, if you are not able to draw this structure, you cannot do this question. So nomenclature is very important in a way. So butyl is available in nature in 4 forms. One is this, another is this, another is this, another is this. Butyl radical can be available in 3 or 4 isomeric forms. One is this, and another is this, and another is this, and one is this. Now if I write their common name. This can be said as N-butyl. This is called as sec-butyl or secondary butyl. This is isobutyl. Now the fellow is, we are clear with, this is tertiary butyl. Now the fellow is talking about this part, secondary butyl acetate. Now we have to figure out what is secondary butyl acetate. So let me draw it here first. So this is secondary butyl, and you have to place acetate group here. So this is the acetate part. So this is the compound which is given to you. Now let us discuss what exactly do we mean by pyrolytic elimination. Pyrolytic elimination is an elimination where a given ester or benzoate or xanthate is being heated such that it results in the formation of, so here I shall be writing it like this. If I draw it like this, alpha and beta, if I draw it like this, so basically what basically I do get here, the beta hydrogen here of the alkyl part, beta of alkyl, because alpha beta can be defined on this side also of the function group, alpha beta something like that. Now here the beta of alkyl part I am talking of, if you take that one into consideration, so what would happen, this H goes out, this bond goes here, this goes here, or you can show it like this also, this goes here and this goes here. Beautiful. So what basically you end up getting here is O negative, and here you get a double bond, and between CH2 you get a alkene, and along with it one H positive also has gone out, that H positive attaches here. So basically there is a formation of, if I do it without sort of a mechanism, so this is what you have got, acid along with alkene. So now we have to figure it out what type of alkene it is being generated. So he is talking about butene from that part, transbutene, cisbutene, butene 1. So all of these things are being asked. And there is also a terminology written here, syn periplanar. So we have to understand the stereochemical part attached with this particular discussion. So for the stereochemical part, we need to understand there are two types of conformations available. So this is beautifully shown here that this carbon-carbon single bond can rotate. This carbon-carbon single bond can rotate. Now, if in case this X and Y, which is being shown in the diagram, so this is nothing but sawhorse projection of the three-dimensional molecule. This is the way to represent it onto the slide. So basically this if X and Y are on the same side, we say it as syn. This is called as syn conformation. On when this X and Y are almost opposite to each other, we say it as anti. Now the term is periplanar. Periplanar means that if I place it one plane from here, if I pass one plane from here, let me select it with some thing like in the gray. So if you place a plane from here, if I am able to draw it, so if you pass a plane from here from the center, so you can see that and X and Y attached with a carbon-carbon single bond, they come in one plane. And similarly, this can also come in one plane. You can see it here. So if they are in same plane, we call it as periplanar. And if the X and Y are in same side of that plane, we call it as syn periplanar. Otherwise, it can be said as anti-periplanar. So let me rub it from here so that you can see into it once again. Now going forward, so we have understood there are two types of conformations available. So let me show it like this. If I draw the same, if I select the same colors, I would say it like this. So this is what you get from here and here. So we shall be getting something like this. So, oh sorry, I should have drawn it like this, and this has to be drawn it like this. So what we are suggesting here is this is X and this is Y, and on this side this is X, this is Y. So this is Newman's projection of the same thing. This is what you call it as Newman's projection. It would have been good one if I would have used the same colors, but it makes sense that if X and Y, here also you could see that this X and Y are in same plane. If you could see here, if in the vertical plane, if I draw it, if I show it to you in the dotted line, this are in one plane, these are in one plane. So you are clear with it. So now going forward, so you are aware of the fact that now that there are two types of conformations available. Now what is the role of this stereochemistry? Now I am coming on to the main topic. So when I talk of what is EI, what is EI, elimination internal. When this substance is being heated, we have said that it generates carboxylic acid and alkene, provided the alkyl part of the ester has beta hydrogen. So how does it look like? So it would look like this one. So if I show this as to be alpha and this as to be beta, now you could see that this beta hydrogen, when they are in syn periplanar geometry, what would happen? So this can interact, and once you heat it, what you would get is something like this six-membered transition state. So this is six six-membered transition state. Six-membered transition state is being generated. Any reaction which goes in a one step through a cyclic transition state is called as pericyclic reaction. So what basically do I get here is something like this. Wow, beautiful. So what you end up getting here is, if I pick the same colors, it would take time. So you would get a double bond. Along with it, this red would come here and the blue lines would come here. So you would get a alkene. Along with it, what you are getting is something like this, RC. This O would get a double bond, and here you would get a OH. So you get a carboxylic acid. So let me explain once again what I did. So this is called as EI elimination. Elimination internal within the molecule, and that too happened in a concerted manner. Concerted reactions or concerted manner or concerted pathway is the one in which bond breaking and making took place simultaneously, because the reaction has gone through a transition state. So the reaction which happens to go through a transition state would be said as a type of a reaction which we named it as pericyclic reaction. Now the question is here, the matter of the fact is that why isn't happened through the anti-periplanar type of a geometry? If it had been an anti-periplanar geometry, this hydrogen and this oxygen are distant apart. So these are distant apart. So there is no possibility of such distant apart. There is no possibility of such elimination, even though you heat it. So it would happen to adopt, if in case, although I have written it across, it can undergo elimination. Once you heat it, it will this conformation would rotate and would acquire the same geometry, the eclipse one, this eclipse one geometry it would acquire, and then it would generate the desired alkene. But if the directly the something is asked that this reaction or this particular conformation would on heating generate alkene, we would say no. First it would um, undergo conformational change, it undergoes a rotation and adopt that syn periplanar geometry, and then would do the same thing. Now the question is, here we have been asked the secondary butyl acetate. I do say it here that at times I have seen, if the molecule is shown it like this, people get confused. What is this AC? AC is the same acid. So this is sometimes also simply be written as AC, and there is a O, so this is O, and dash and dash. So this and this are one and the same thing. So it is nothing but to ask the same thing in a different way. Now, if I simply would do without any sort of mechanism, what basically we do see here, that we need to check the alkyl part of the ester. So the alkyl part is alpha, this is beta, and this is beta dash. So there are two types of beta available. So if I rotate the H from here, from the one which I am showing with the white marker, this bond goes here, and this goes here, and this goes here. So you get to see the formation of alkene as butene 2. So this would generate a butene 2, and if I use this orange marker this way, it would generate same thing like this. Then you end up getting butene 1. That are the things which is being asked in the options, and along with that you always end up getting carboxylic acid. Now the question becomes very interesting, that butene 2 may also be generated and butene 1 also is generated. Very interesting and engaging question, although to begin with it seems like a easy one. So this butene 2 is available in nature in two forms. Again, this is very interesting, cis and trans. So he is asking whether it would go for the cis one or the trans one. So make it a point, in the organic chemistry, if the starting material engages stereochemistry, it becomes interesting, or in the option there is options are given such a way that it engages stereochemistry, then also it also becomes very engaging. So such reactions, such type of reactions are very, very interesting. I shall be making one videos exclusively for those reactions which engages good amount of stereo selectivity and stereo specificity, but in the later stage. Now let me come on to back onto the discussion. So it has to adopt the same periplanar geometry, this is for sure. And now let me do it for you how it is to be dealt with. Now the point is that if you happen to say this has to be alpha and this is to be beta, so there are two types of beta available, as I said, beta and beta dash. One is beta and another is beta dash. Now if in case I take the beta first, so if I take the beta first, this is the beta one. So what does it mean? So this CH, and on one side there is a CH3 and there is H. And now if I talk of this CH3 which is on the next carbon on which the ester part is there, let me show it to you with the blue marker. This CH is this one, and this C which I am marking it with blue, this C, let me mark it with blue, this C is attached on one side with hydrogen and another side with methyl. So here what you have to understand is that on one side there is hydrogen, on other side is methyl. But you may also take it like this also. This is H, this is methyl, and you can take this as methyl here and H here. Now this again is very interesting. So if methyl and methyl are on the same side, during its elimination, if this bond has happened this way, wow. So what you end up getting here is a compound which would be a sort of cis 1 along with the acid. And if this methyl and methyl are opposite to each other, these are trans type alkene it would generate. So it would generate a trans type alkene. So on this side you have methyl H double bond, on this side this is methyl and H because this is distant apart. Now the matter of the fact is that which way it has to be dealt with. But there is one more option available, that is of the beta hydrogen, beta dash. If I take the beta dash this side, if I say this as alpha, this is beta dash. So on the beta dash, what are the things? On the beta dash, there are three hydrogens. If you could see very categorically, I am marking it with green marker. This is having three hydrogens. One hydrogen I have already shown, this another hydrogen, another hydrogen. On the other side, what you would see in the green side is this one. On one side, there is a hydrogen and ethyl group. So let me write one hydrogen and ethyl. So this is hydrogen and this side you have ethyl group. Now what would happen if I do the elimination this side? So this would go this side and you end up getting here is CH2 double bond CH, because this is CH2 double bond CH2 CH3. So this is but one ene. Now the point is you have to identify what has been the answer. That we got a feeling that because the starting material nothing is being mentioned, they simply have said secondary butyl acetate, secondary butyl acetate. So secondary butyl acetate can have all of these which we have shown here. This also is a very interesting one. If I happen to write this as 1, this as 2, and another one 3, all of these are nothing but conformations. This is this is the conformation between, let me mark it very categorically here with the yellow marker. This is between 1, 2, this is 3. So these two are the conformation between 2 and 3, and this is the conformation between, oh sorry, this is the conformation between, this is the conformation between 1 2, 3, 4. This is the conformation between 1 and 2, and this is the conformation between 2 and 3. Now what way we have to decide? So here the viewpoint is that the product formation would be high. The elimination product or this transition state would be stabilized if there is lesser steric repulsions. Here you would see there is more repulsions. Methyl would repel the methyl. So there would be, so that transition state would be highly favored where the uh, uh, steric repulsions are least, or the groups, bulky groups are, if they are close to each other or they vis-a-vis, out of the three possibilities, the one, that transition state would be favored in which the intermolecular repulsions or interatomic repulsions or intermolecular interactions is such that the repulsions would be minimum. So now see here, here the methyl and methyl are distant apart. So here there is lesser repulsions. So if I talk of this two, I would say trans is favored compared to the cis. If but2-ene is being formed, and this is cis is less favored. This is less favored because the transition state through which it came has good amount of repulsions. This is less favored. So if in case but2-ene is formed, we will be saying that trans predominates upon the cis. Now between but2-ene and between 1-ene, which is the right answer? So here what you are seeing, this hydrogen is behind the hydrogen. Here the hydrogen is being repelled by ethyl, and the ethyl part is also consisting of, let me show it here, because at times you would feel that this ethyl is a bulky group. No, this again is having a hydrogen and it goes distant apart. This methyl goes distant apart from this hydrogen. So this is the most favorable transition state. Here we shall be saying repulsions are the least one. So this is most favored. This is most favored. So we would be concluding it like this, that pyrolytic elimination of esters do adopt syn periplanar geometry. If I talk of syn periplanar geometry, and it would give you a alkene which is in accordance with Hoffman product instead of sets F. Hoffman product is the one where the reaction has possibility of formation of more alkylated, less alkylated alkene. Here the formation is favorable for less alkylated alkene, because stereochemically the pathway which governs the minimum repulsions is the answer. So but2-ene is majorly formed. So here is a very beautiful statement here written for you, which I can show it like this, that pyrolytic elimination occurs in case of acetates, benzoate and xanthate through a six-membered transition state in a concerted manner or concerted pathway. So we shall be saying this is xanthate. This would go like this if you don't want to engage the stereochemical part. And here this is nothing but benzoate, and this we have already done is what you call it as acetates. So this was a interesting question. So let us first solve the answer to this particular question, what is being asked here. So the problem was but2-ene is majorly formed in major quantity. This is a perfectly right statement. But2-ene is formed in major amount than cis-butene. So this also is the correct one. But1 is majorly formed. Okay, but2-ene is in minor quantity form. This also is a right statement, and butene 1 is in majorly formed is right statement. Now let us see the D option, what is being written here. Among but2-ene, cis isomer is only formed as it adopts syn periplanar geometry more effectively than the trans. This is a wrong statement. Cis, although it can adopt the syn periplanar geometry, but it is not favorable because the most favorable is being adopted by during the formation of but1-ene, and out of cis and trans alkene is majorly formed because that adopts better arrangement. So it has been seen that in this particular question, if I talk of the product of these, the product of this is but1-ene and but2-ene, and but2-ene is available in two forms, cis and trans. Cis and trans. So it has been seen this is majorly formed. Trans is among but2-ene, trans is being formed, although all are formed, but this is almost 57% formed as per the data endorsed in some foreign author books. So it is 57% formed, and rest of this is being distributed in this, but trans is more than that of cis along with the formation of acetic acid. So this is a very beautiful question. I hope you have understood. I touched many aspects, nomenclature I touched with, then the conformation, cis and syn periplanar, anti-periplanar, and some other day I shall also be explaining that there is a Cope's elimination, which in a way is the same sort of a reaction, which again involves EI elimination. Syn periplanar geometry is required in this case, and this also engages a Hofmann product. So in this, basically tertiary amine N oxide is being heated in such a way that it adopts in only difference that it adopts 5-member transition cyclic transition state, 5-membered cyclic transition state. So problem based on this I shall be discussing some other day. Here I shall just be explaining a bit of viewpoint that how does it has happened. So basically it also gives you a alkene along with a an oxide type of a compound is being formed because of this intermolecular hydrogen bonding. Within the molecule, this generates a hydrogen bonding. So I hope you have understood all the things which we have done in today's session. Hope you liked this and would gain many aspects of the organic reaction through solving this particular problem. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.